Hello everyone, I'm Professor Xiaonan Gao. Welcome to the General Chemistry class. This session will finish the gases chapter. The simple gas laws, such as Boyle's law and Charles' law, were based on the behavior of air, a mixture of gases. So, the simple gas law and the ideal gas equation apply to a mixture of non-reactive gases as well as to individual gases where possible. The simplest approach of working with gaseous mixture is just to use for the values of N the total numbers of moles of the gaseous mixtures. John Dalton made an important contribution to the study of gaseous mixtures. He proposed that in a mixture, each gas expands to fill the container and exerts the same pressure, called its partial pressure. That is, would if it were alone in the container. Dalton's law of partial pressure states that the total pressure of a mixture of gases is the sum of the partial pressures of the components of the mixture. For example, for volume and temperature constant, if the gas A has a pressure of P1 in the container and gas B has a pressure P2 in the container, by mixing the two gases into the same container, the pressure total equals P1 plus P2. Let's consider a case in which two gases, A and B, are in a container of volume V. Then PV equals NA RT over V. NA is the number of moles of A, and the same for B. The pressure total equals PA plus PB. The mole fraction XA equals NA over NA plus NB. Therefore, the partial pressure PA equals XA times PT. And more generally, PI equals XI times PT. We can use the Dalton's partial pressure equation for gas mixtures of any kinds. A sample of natural gas contains 8.24 moles of methane, 0.421 moles of ethane, and 0.116 moles of propane. If the total pressure of the gas is 1.37 atmosphere pressure, what is the partial pressure of propane? From PI equals XI PT, firstly, to get the mole fraction of the propane, which is 0.0132, then the partial pressure of the mole equation of the mole fraction of propane times total pressure
1.37
ATM, the answer is 0.0181 ATM. Let's recall the preparation of oxygen in lab. Still remember the picture, right? Does the bottle only collect pure oxygen inside? Actually not. Water vapor is also inside, so it is wet oxygen. The pressure total inside equals the pressure of the oxygen plus the pressure of the vapor. The saturated vapor pressure depends on the temperature change. Basically, from 0 to 100 degrees Celsius, the water vapor pressure increases, which correlates with the ideal gas law, since N and V are constant. The last part of this chapter is a gas diffusion. Gas diffusion is a gradual mixing of molecules of one gas with molecules of another by virtue of their kinetic properties. The higher molar mass, the slower it travels. Let's look at this picture. Two bottles with concentrated ammonia and hydrochloric acid each were placed on the table with caps off. Since both of the gases are volatile, they meet on top of the hydrochloric acid to form ammonia chloride, the fog. Why on top of the hydrochloric acid bottle? Because its molar mass is higher, so it diffuses
slower
than ammonia. Alright everyone, in this class we learned the mixture of gases, Dalton's law of partial pressure, and gas diffusion. I hope you have enjoyed the class, and I'll see you next time.